Okay, so welcome to another episode of AMath Tutorials with Little Music Bear. I believe as the AMath O-level examinations are coming around the corner, this will probably be my last AMath tutorial, but next week I will still release a list of revision guides, but I will not be focusing on any topic anymore. So this question for linear law was quite requested in high demand, so I decided to just master it and go through how I solve this. Okay, so first thing, when you do a question of linear law, don't get yourself confused by all the words at the top right here. Usually part 1 wouldn't involve the entire sentence over here and the formulas. You'll need this in the later parts. So even if you do not know what all this stands for, just ignore it first and draw the graph. So now they ask you to draw the graph of ln v plus 3 plotted against t, and they give you the scale. So you should underline the scale first. 1 cm for 1 unit on the t-axis, and 5 cm for 1 unit on the ln v plus 3 axis. So now, but the question is, they only give you the values of t and v. So how do you find ln v plus 3? Use a calculator. So let's try one. You can create one extra row at the bottom of the table for ln v plus 3. So ln v plus 3. Okay, so first one, when t is 2, ln v plus 3, v is 6.35. So you just take ln 6.35 plus 3. There you get a 2.235. But since they give all in 2 decimal places, we can just stick to 2 decimal places. But to make the graph more accurate later on when you plot, you may want to add extra dp, so we just put 2.235 for now. If not, the points may go a little bit off. Maybe 1 extra decimal place will work fine. And when t is 4, v is 4.38. So ln 4.38 plus 3, we get 1.99877. So 1.999. And repeat this for the next 2 readings. So you may pause this video while you find out the readings. I'll show them later. Okay, so done? Do you get all the readings? No, great. Next, we have to draw the axis. It's recommended for you to always use a ruler when drawing this axis for straight line graphs to ensure that its accuracy. So here we go. Remember to label one side as t and one side as ln v plus 3. So t will be on a horizontal axis. Now we see the range first. You have 2, 4, 6, 8. For v, or ln v plus 3 on the vertical axis, we have the range from 1.48 to 2.23. So 1 to 3 will be a good option, but you need the origin, so 0, 1, 2, 3. Now estimate 5 cm per unit. So 5 cm is 5 boxes. So here. So if we start from here with a 1 box allowance, we'll probably have enough space. So we'll draw the axis here, all the way down. Okay, and the top. Ln v plus 3. Then next, locate the origin. I think we'll just have it here. Since the values don't go negative, we can always have the origin lower. 0, 1, 2, 3, 4, 5. And here's a 1. 1, 2, 3, 4, 5. It's a 2. 1, 2, 3, 4, 5. Here is a 3. And that's how you do the axis. So for t-axis, once again I'd like you to pause this video and try to complete the other axis. Once you're done, play to check your answers. Okay, and done. And we'll label this side T. Okay, so now it's time to draw the graph. We'll have to plot the points. I believe you already know how to do this. Since plotting points is one of the most straightforward things, you just find the readings when t equals to 2. Look for 2 here, and it's 2.235. So estimate, so this is 2.2. And this is 2.4, so 2.235. Each one will be 0.04. So it'll be close to the first line here. Yep. And for the rest of our points, do continue plotting first. And you can pause this video while you plot. Okay, so now you're done with the graph. Since this is, you look at the points, it's a straight line graph with a negative gradient. So join all the points together. Okay, use the graph to estimate the value of the constants a and k. This is a 5-mark question. So, before you do anything, you have to express this equation first. So, if you don't know what to do first, you copy the equation. V equals to a b t over k minus t. Now, when you meet this equation, you see an e here. So, if there's an e and you want to get rid of the e, you can always use the logarithmic function ln. In the question, they ask for ln b plus 3. So here we have the 3 here. So we can put the 3 in first before we ln. Since there's an e here, so it'll be b plus 3 equals to this. Now it's time to ln both sides. Okay, now we're done with this. At this point of time, you have seen that this side is a similarity to the y-axis on the graph, which is also ln b plus 3. So this one basically will be your so-called y. But in this case, in the question, there isn't a need to write y. Next, we have to take the t out. So this can be continually split. Since we already have this ln b plus 3, we can just leave it. This is what we want. So ln e is equals to 1. Okay, and you can split this up using the addition law of logarithms. So you get ln a plus ln e power of t over k. So ln a is now your so-called c in the straight line graph, and the t will be the x. So we have to further separate this. Once again, equals to ln a plus because ln e is 1. You can start here to take note, which means that you can cancel away, you've got rid of the e. Okay, right here is extremely simple because you have only possibly less than 3 steps left. On v plus 3. Since your t is on the x-axis here, we can take the t up. So it'll be 1 over k multiplied by t plus ln a. And then we've got this form over here, y mx plus c, which is the standard formula for a straight line graph. So now we already seen. Now next, from the graph, we need to find the intercept when this equals to 0, the entire thing is 0, so we can find what is ln A. When t equals to 0, 1 over k is to multiply by t is also 0. So now let's look at our graph here. So it's 2.5. So from the graph, ln A equals to 2.5. Because if you need an extra step, I can show you. Basically, it is 0 plus ln A equals to 2.5. Since this is already 0, it's just ln A equals to 2.5 is equal to e to the power of 2.5. Use your calculator to find e to the power of 2.5. You get 12.18 round off the 3s as equals to 12.2. Okay, last thing, we need to find the k. The gradient of the graph is 1 over k. So using the gradient formula, draw a triangle, you can do it. Gradient equals to 1 over k. Because this is the n from the standard equation. So to find k is the reciprocal of the gradient. So go the other way around, which is x2 minus x1 over y2 minus y1. Basically the other way around. Pick the points from the graph here. So I will just pick a larger range, so let's say here 2.235. Then we'll pick this also 1.484. Okay, so this is triangle to find the gradient here. Equals to negative 7.99 PSF. To check your answer, you can always substitute back to the original equation, but if you're running out of time, I believe there's no need to. So total 8 marks for linear law. The rest of the other marks are pretty simple, you can do it yourself. You just basically sub in the figures you get from your A here and your K here. And that's it for AMath Tutorials with the Music Bear podcast. Bye.